Yes, class. So yesterday we had seen questions from ray optics, objective questions we had seen. Today we'll start with wave optics. If time permits, then I'll start with electrostatics as well. Otherwise, let us try to complete the second book today. So be thorough with second book. In the next weekend, I'll take a test of complete second book. Class test only I'll take of the entire second book. So modern physics, semiconductors, and your optics. Already you people are prepared, so you don't have to prepare anything separately for this. Whatever you have been preparing, just studying, just practice the main important questions from the lessons. That will be just sufficient, because now you should be ready for any type of tests, whether first book, second book, or the entire syllabus. So second book I'll test, but on next Saturday or Sunday. Fine. So see, Heinz principle we had started with when we were doing wave optics. We have the first concept of wavefront. Then depending on the type of the source, we have three types of wavefront. If it's a point source, we have spherical wavefront. If it's a linear source, it produces a cylindrical wavefront. If it's a plane wave, if it's a very, very distant source, means your source is located at infinity, then we get a plane wavefront. If you are having a source which is producing diverging rays, so you get diverging wavefront. If the source is producing converging rays, so you get converging wavefronts. So these types of wavefronts are available. Then you have Heinz principle. This is the most important topic from this lesson, because if any theoretical part is asked, questions are usually asked from this part. Describe or state the laws stated under Heinz principle. How is the proper, or another name, if directly the word is not mentioned, no, so directly it will write, indirectly it will write how the forward progression or propulsion of the wavefronts occur. So then you have to describe. Firstly, you'll mention all these terms. Each point on a wavefront acts as a fresh source of new disturbance, which we call secondary waves. Then these secondary waves spread in all direction in the given medium. Then new wavefronts, when you drop the forward envelope, means dropping a tangent on the primary. This is the source. These are the primary wavefront that are formed. Each point on it will act as a fresh source of new disturbance. So you will be having secondary wavelets. If you drop a tangent on all of these, you'll get a new wavefront. So this is how it has moved further. Similarly, all these will act as fresh source, and so on. It will keep on moving. And the speed with which they move is the speed of light. Then we had seen the behaviors of all these. This is a question. Yes, sir, these two part also come to prove reflection. And last year, I think, or last year, in one of the recent papers, it has come that in one set, it was given the prove reflection on the basis of wave theory. And in second set, it was given prove refraction on the basis of wave theory. So reflection and refraction on the basis of wave theory are asked. So directly remember this, whatever we have done in the class. All of you, I hope, have the links for these. I have shared it on the group. So those, if you people are not added on the group, if you do not have access to the drive links, so let me know. I'll share these OneNote link with you. Derivation, yes, Fahad. The derivation only I'm talking about from the wavefronts part. No, yes. Of this topic, refraction and reflection, this is a kind of derivation only. When you're talking about refraction and reflection on the basis of Heinz theory, it is actually one of the types of derivations only. So among the derivations, refraction and reflection, and it's not like either of them is important. Both of them are important, because I have told you in one set it can be given to you as refraction, in another set it can be given to you as reflection. So remember both of these. This is very easy to remember. You can remember, just you have to prove Snell's law in refraction, and angle I is equal to angle R in the reflection one. So these two are also important from Heinz principle. All right, then we have interference. Let's do one thing. From Heinz principle, you just have basic questions, very basic questions that are usually covered in dual nature of radiation and matter, which relates refractive index with speed of light in vacuum and medium, these topics that are done already. So one or two questions let's practice from this, then morely we'll focus on interference. Okay, I'll be focusing again on objectives now today. So whatever is your answer, A, B, C, D, whichever part, just mention me the part. And again, I'm repeating because many students were not there yesterday. Whenever you are appearing for your exam, whether it's mock tests of here, Learnivio, you're appearing for your board examination, while writing answers, if it's MCQ, mention the part which you are answering. Like for example, you're answering question number 1 and your answer is B part. You think B part is correct. So write question 1 and then first mention B part, then write whatever is given under it. Because most of the marking schemes have just ABCD written. So if ABCD does not match with your answer, suppose you have written the answer is, let's say, 2 millimeters. So B part, then 2 millimeters, write like this. Don't simply write 2 millimeters. Many students have done this in the in the mock tests also, which have been conducted here while I was checking. Many students have done this. They have just written the inner part. So here I have given marks, but it can happen your marks it can get deducted in your final board examination. So before it gets deducted, just be on the safer side. Write the part, whichever is your answer. Part number is given, ABCD is given in whichever form, 1, 2, 3, 4, ABCD, whichever. First mention that after your question and then write it. Fine, because otherwise it might happen that your marks can be deducted. There are chances. Fine, so that just keep in mind. So same way here also, today you can answer me ABCD. That would be better. So I'm writing the question first, then you people try it, then we'll discuss it. Donna, I forgot to ask you yesterday, how was your exam, practical exam?
Ma'am, the one I had yesterday is the mock exam. The final exam is in this week.
Final exam is?
This week.
Okay, okay. That was mock exam.
Yes.
So how did it go?
It was okay.
Okay. So are you all through your practicals, final board examination practicals, or are they about to happen in this month? Because every school has different timings, no, for these practical, external practicals which occur. Okay, okay, they are about to happen. Yes, class, 5 minutes are over. Only Fahad has answered correctly. Last 1 minute, then I'll discuss it. See, this is very easy question. No usage of actual wave optics. Simple use the relation between refractive index, speed of light, then try to find out time. Use your kinematics, time, distance by speed, that relation. You'll get your answer. See, class, I'm discussing it now. Look here, it says calculate the time light will take to travel normally through a glass plate of thickness 1 millimeter. Rehan, your answer is right. Good. Refractive index is given. Speed of light is not mentioned because we all know the speed of light. So velocity in glass, when you calculate, velocity in glass will be speed of light by refractive index. That's how we write. No, refractive index is speed of light by velocity in any other medium. So in any other medium, that medium is glass right now. So velocity of glass is speed of light divided by refractive index. So 3 into 10 to the power 8 divided by 1.5, I'll write it as 3 by 2. So that will be 2 into 10 to the power 8 meter per second. Look here, class, be careful when you're answering such types of questions because MCQs also will be there, no, in your section 1. This is meter per second. So in a hurry, this option can look like 2 into 10 to the power 8 second as answer. Now, thickness of the glass plate is given as 1 millimeter. That is 10 to the power 3 meter. So this is the thickness. It's like this much amount of thickness has to be covered with this speed. So time will be what? Time is going to be simply the thickness divided by the speed. Thickness is 10 to the power minus 3. Speed is 2 into 10 to the power 8. So 0.5. So 8, 11, minus 11. Then minus 1 is there. So minus 12. So 5 into 10 to the power minus 12 seconds. So D option. Written the above part, the solution. If anyone is writing, let me know. We have interference then. Interference means two waves that are moving or propagating, they superimpose with each other. They interfere with each other's path. So that is known as interference. So yes, you have path difference, you have phase difference, and there's a relation between path and phase difference. Phase difference is basically the angular difference that arises. Phase difference is basically the angular difference that arises. If a wave is moving like this, another wave is moving like this. So this angulation difference that is arising, one is located at this angle, another is located at this angle. So this angle difference that is coming, that is known as phase difference. And this path is there of this wave, and this path is there of this wave. So difference between their path is known as path difference. Yes, see, case-based study, these case-based studies questions which are there, case study questions. In your section D, I think, no, section E, you have one question that comes a long question. So that will be random, Fahad. See, you cannot predict it because a whole lot theory will be given. Long theory will be given from which the usages will be used from all the lessons. So it is not from a single chapter, Fahad. It is from a unit. Usually these case-based studies, questions are made from particular units. So like you have optics. So it can use ray, wave together and form such a question like the last question which we did just now. That was not a particular question. How will you categorize it? Under wave or ray? You cannot. It's a part of both. So such types of questions are also used, or particular questions are also used. Definitions can be as one value based is also asked. No, one value based question is also mentioned. So that is not specifically from a single chapter, that is from all the units. So you have like electrostatics unit. So from the electrostatics unit, just a second. So from the electrostatics unit, you have all the topics with you, potential you have. So it can happen from capacitor, a case study based question come. So that is not definite, that will be just applied on the spot. So don't study it chapter wise, or don't focus it from chapter wise. It will be from unit wise, number one, and secondly, that is unpredictable. From which unit it will come, it is not mentioned. It can be from your semiconductors also, right? So it can be from any of the lessons. But be prepared, whatever you have studied, only those portions will be used. Just a long history will be written that is of no use, from which you have to identify whatever physics you have studied. Fine, so phase difference and path difference are there. This is a relation phi by 2 pi is equal to x by lambda, where phi naught is your phase difference and x is your path difference. Superposition principle involves just algebraically you're adding all the waves, vectorically, sorry, you're adding all the displacements of the waves. Superposition principle remains the same everywhere for any physical quantity. Now, sources emitting light waves of same frequency, wavelength, constant phase difference, we call it as coherent source, and just opposite to it are non-coherent sources. So phenomena, this definition class I'll mark here when you're referring it in your notes also. Use this definition only. Phenomena of redistribution of light energy due to superposition of light waves from two different coherent sources. This phenomena is termed as interference. Then you have Young's double slit experiment. You have a very central maxima from here, central bright fringe you get, then alternate dark fringes and bright fringes you start getting it. Wherever the waves constructively coherent with each other, constructively coincide with each other, you get bright fringe, because that results in a greater amplitude like this. Crests and crests getting added, troughs with troughs getting added. So you get bright fringe. If opposite occurs, then we call it as dark fringe because of destructive superposition. Anyone has any doubt, let me know. Then these are not very important. This entire derivation is not very important. Can be asked, anything can be asked in your exam, but this is not very important. From this topic, what is important is the application of this formula, or applications of all these formula, rather, I would say. Resultant of amplitude, all these will be used. Questions will be there from these topics. Derivation is not necessarily very important. Same way with intensity. Intensity's formula is very important. Some topics are there, no, whose formula is more important than the derivation. So this is one of them. Then we have destructive and constructive interference. Then you have interference with white light. In interference with white light, you get a perfect combination of the Vibgyor colors. You have all the Vibgyor colors lined totally. Then intensity distribution curve. Yes, this is important because you can get a comparison of intensity distribution curve of interference with that of diffraction. So this becomes important in that case. So we know for non-coherent sources, these are independent. Pi and intensity, phase difference and intensity, these are independent. For coherent sources, they get a maximum value at 4i, then back to 0, then maximum, then back to 0. So such a graph you get. All right, then you have fringe width from Young's double slit experiment only. Fringe width is simply beta is lambda capital D by small d. Now, what is the meaning of each term in this? This is the source slit. This is the screen. So the separation between the slit and the screen, this is small d. Right, this is capital D, sorry. And separation between both the slits, this is small d. And wavelength of the light that is used, is lambda. So beta is fringe width, fine. Lambda capital D by small d. So how do you write fringe width? Lambda capital D by small d. And if let's say n number of fringe widths are formed, you are not aware what is the number, just multiply it simply by n. But this is also not used so much. Lambda d by d is enough. Diffraction we'll do later. First, let us practice some questions from this topic. So you have to use the resultant. Yes, yes, that equation only which you are mentioning. So that equation only. Amplitude of resultant wave. Resultant waves equation is there, which I think I had shown you also just now. So that equation you will use, you will get your answer in one single line because the values of amplitudes are given A and 2A. All right. Yes, yes, this form, right. Cos phi will be there. Yes, class answers which option is right. This is a question from 2003 sample paper. How much you're getting? A root 4.5. No. Mm-mm. See, A will be there in your answer, no, in your options. You can add this. In this question, I don't know why it was not given. A will be there. A will be there. But 4.5. Okay, let's see. You have A1 as A, you have A2, you have A2 as 2A. The phase difference is pi by 3. So equation of the resultant amplitude, this is resultant is A1 square plus A2 square plus 2A1 A2 cos phi. Fine. This all will be under the root. So resultant will be, just a second. See, under root A1 square plus A2 square plus 2A1 A2 cos phi. So A square, A2 is 2A. So 2A whole square plus 2A into A multiplied by cos pi by 3. This all will be under root. So this is A square plus 4A square plus, so see, cos pi by 3 is there, and you have 2A square. So 2A into, so that will, this will become half. So how much is left? Half into 4A square. So 5A square plus, this will become 5A square, 5A square, 9A square. Then you have minus 2. So that will be how much? Root 2, 6, 7, 7A square, right? So root 7A square, that will be A root 7. So answer B option. Yes, Asta, B option, right. It says that in a two-slit experiment with monochromatic light, fringes are obtained on a screen at some distance capital D from the slit. So if the screen is moved 5 into 10 to the power minus 2 meters towards the slit, so you have to see that the change in the fringe width is 3 into 10 to the power minus 5. So if that separation between the slits, the small d that we take, no, this separation, this is 10 to the power minus 3. You have to find out wavelength of the light that will be used. See, you have to find out the difference here. Let's say one is beta. Let's say this one is beta. So beta will be lambda capital D by small d. Let's talk in the other case. Let's say it's beta dash. So let's say capital D dash. Lambda will remain the same, and the slit width will also remain the same. So if you take the difference between them, beta minus beta dash, that becomes D minus D dash will be taken common. And how what will be left? Lambda by small d. This much will be left. So lambda you can write it as beta minus beta dash multiplied by small d divided by capital D. This much you can write for lambda. Now see, d minus d dash. So here will be d minus d dash. This term d minus d dash, whatever is the separation or how much will the distance be obtained if the screen is moved, that is already given in the question. I think 5 into 10 to the power minus 2. See, if the screen is moved 5 into 10 to the power minus 2 towards the slit, it means this was earlier d, this is now d dash. So what will be, this is moved 5 into 10 to the power minus 2 meters. So how will you write it? The separation will be d minus d dash. So you already have d minus d dash as 5 into 10 to the power minus 2 meters. Fine. Then you have separation between the fringe, which is also given. It is said no change in fringe width is something 3 into something. Beta is how much? See the change in fringe width, that is beta minus beta dash. The difference, this is 3 into 10 to the power minus 5. So this will become beta minus beta dash. This will become 3 into 10 to the power minus 5 meters. And small d is given 10 to the power minus 3 meters. So lambda will become 3 into 10 to the power minus 5 meters multiplied by 10 to the power minus 3 divided by 5 into 10 to the power minus 2. So how much will be left? 30. This will become 30. So you will have 6,000 angstrom will be the answer. Here the calculation is obvious. The answers will be in terms of angstrom only. So first unit identification help. These, if it comes in your MCQs will be obviously of 1 mark. But if it comes, this will be not less than 3 marks. So note it down. This is the wavelength for it. Look here, class. A beam of light consisting of two wavelengths. One is 800 nanometer, another one is 600 nanometer. These are used to obtain the interference fringes in YDSE on a screen placed 1.4 meters away. Okay, Asta has answered. Anyone else? Only Asta has answered. See. Devangi, you don't have class right now. Your class has still 40-45 minutes left. All right, Devangi. This is class 12th going on currently.
Okay, ma'am.
So, two wavelengths are there, 800 nanometer, 600 nanometer. Their screen is placed 1.4 meters away. If these two slits, they are separated by 0.28 millimeters, you have to calculate the least distance from the central bright maximum where the bright fringes of the two wavelengths coincide. Look here. Two bright fringes will coincide at the least distance. Let's say that is x. X is the least distance. So the path difference x, which we write, this will be n lambda 1 capital D by small d. This is 1 because two bright fringes are coinciding. So the next one will be n plus 1. That's how you write, no? First one, then the next one. So that's why we are writing it as n plus 1, then lambda 2 by capital D by small d. They get cancelled. You are left with n lambda 1 is equal to n plus 1 lambda 2. Now n into 800 nanometer is equal to, this is n plus 1 into 600 nanometers. So this will become 0, 0 will get cancelled, 4 and 3. So we can write this as 4n is equal to 3n plus 3. So n will become equal to 1 is equal to 3. No? So 3. N is 3. Now you have the value of n. So calculation of x is not difficult now. X will be 3 lambda 1 by small d. So 3 into capital D will be 1.4. And wavelength was 800 nanometers. So convert nanometers, 10 to the power minus 9. Divided by separation was 0.28 millimeters. So 10 to the power minus 3. The correct answer for this becomes 12 into 10 to the power minus 3 meters, which is written as 12 millimeter. So not option D, this is option A. So A option is the right answer. Note this down, then I'll revise diffraction with you all. Last topic for today.
Ma'am. Ma'am.
see last topic, diffraction. So diffraction was what? If the light rays strike the corners of any obstacles, it bends itself. So a region of geometrical shadow is created. This phenomena is known as diffraction of light. So from diffraction of light, you have mainly Fraunhofer's diffraction. Fresnel's diffraction is not used. Questions from Fresnel's diffraction are not given in your examination. You have Fraunhofer's diffraction. If anything is asked from Fresnel diffraction, it will be relation between D, means separation between the screen, distance at which effect is seen, inversely proportional to wavelength. This can be asked at the most. That too in theoretical part. Then you have diffraction from single slit. Same things you have path difference, angular separation, linear separation. Here also you will get a maxima, you will get a minima. So you have different values of path difference and phase difference and linear separation for maxima. Same thing for minima. Fine. So let's practice some questions from this. Then one or two, I think 2-3 questions are left. Then I'll stop the class. Look here. Light of wavelength. This is an easy question. How much angle are you getting? Angular position means you just have to find out the angle. See, one thing I'll tell you, then try. A sine theta is equal to lambda. Only this formula will be used. Lambda you have, A you have, theta you have to find out. Sine theta, this will simply be lambda by A. Wavelength is given as 600 into 10 to the power minus 9. A is 1.2 into 10 to the power minus 6, this much. So how much is left? This is double of it. So half. So theta will be 30 degrees. And see, angular width of central maximum is always double. Remember, I had told you because 2 theta will be there. No, this 1 theta and this theta. So entirely this becomes 2 theta. So that is 60 degree. This will be angular width. Quickly note this and try to answer all the questions, at least attempt it. See class, for this question, no. Light wave enters from air into glass. This is also one of the question of previous year, 2004, I think, or more than that. So how will the following be affected? Energy of wave and frequency of wave. See, energy of wave decreases because part of light is reflected back into the air. Energy, this decreases. This decreases because part of light wave is reflected back into the air. So energy will decrease. If this is the amount of energy, this part has been reflected back. So how much is left? Now only this portion is left. So this is lesser than the original one. That's why the energy decreases. And frequency remains unchanged. Whenever you have any question from frequency, always remember frequency will remain unchanged. Frequency, this remains unchanged. So we have covered almost maximum questions from your wave optics and your second book entirely we have done. So next Saturday and Sunday, I'll take your test on the second book. Saturday, be prepared for the test. Then I'll start with the electrostatic revision. So 2 to 3 classes more are needed for your revision. Then only open doubt sessions will be there. So students will be having any difficulty, any doubts, then only those can come. Right now, I think 2-3 classes, one for your electrostatics part, one for your magnetics, and one for the last portion, EMI, AC, and EM waves and all portion. After that, you'll be having doubt classes. Fine. So whatever doubts you are having, no, keep collecting them, mark them. Whenever doubt class will be there, so you can ask. Otherwise, also you can send your doubts on WhatsApp and ask. Fine, class. So you can leave now. That's it for today. Thank you so much, class.